That was one of the postmans. Anyway, greetings, the Astro 30 here, yet again with another fun-filled episode of Astro's Electronics Lab for you. That was a bottle. Now, today I've received a package. I'm pretty sure I know what it is, but rather than say what it is first, I'm going to unwrap it. So, one knife, carefully just pierce the bag, so I can open here and reveal a box. And no, this did not come from China. Yes, it is what I thought it was. It does come from China, but I mean, I bought it from an Australian supplier. So, if we open the box, we see, well, a bunch of potentiometer knobs, a screwdriver, a power adapter, and some spade terminals, I think they are. But what we're looking at the moment here is this. This is a tiny 2.1 Class D stereo and subwoofer amplifier module, and it's called the ZK-MT21. Now, I'm not sure what IC this uses offhand, but it looks like it's also got Bluetooth functionality, and the reason I say that is because there's an antenna connection here. There's no instructions with it as far as I can see, but it has a power DC input, and I'll get rid of that bubble wrap because it's kind of annoying me. And it features a frequency and subwoofer volume for the subwoofer, a treble and a bass, back to front, and the master volume. So this is a 4-gang potentiometer. So if we look under the underside, well, no, I'm wrong, because if we look at the underside, it's actually a switched 2-gang. So if you rotate it fully counterclockwise, it turns off. Those are the switch contacts. There's our input, which is a 3.5mm socket, and it is crooked. Look at that socket, it's twisted, it's like not soldered in straight. I mean, if it really bothers me, I can probably heat these joints up and just twist it a little bit to make it straighter. Looks like a switched 3.5mm socket as well. There's a switch there. I don't know if it's me, but it also looks like the back end of the socket's twisted more than the front end. That's bad. So anyway, that's the amplifier module itself. And as I say, I don't know what IC it uses, because it's hard to actually see. And it's not marked anywhere, but I can pull the screw of the heatsink out and actually have a look at what's written on the chip and if it's got any heatsink compound, which it probably does not. There goes the heatsink. Oh, very little to no heatsink compound. And there's our two Class D driver ICs there. So it's still not marked as to what they are, so I'll carefully just remove that transfer compound off the surface of the ICs, and I'll apply a bit more new stuff before I finished. So let's see if I can now read those numbers. Well, according to what I could read, it says CS8673e, which I haven't actually really heard of that particular IC before. We can always look up a data sheet, but I'm going to put this back together with some more heatsink compound, because I don't really think there was enough on there to start with. It doesn't really take much of this stuff, but it feels like to me that this stuff is way too watery. So I'm going to put the screw back in. I'm not going to tighten it up too much because you'll I'll crack the silicon die of the IC. So we'll put that module to the side. Now we know what the IC is, and we'll look that up. So these are actually standoffs. So they go on the main PCB here in these 4 points to mount this other part, which we've actually got 2 panels here. We've got a back panel. It tells you what the DC voltage is between 12 and 24 volts, and its power outputs at respective, loads and stuff. So these are also PCB material. So we've got a back panel and what would be, well, the bottom panel, and this will be the top panel. And then it tells you the output connections here, right, left subwoofer. At the front of the board, it's like telling you what the controls do, etc. So you've got off and on. So the next thing I would do probably is, I'll put that to the side for a minute, is work out how this would assemble. Now I've got a fair idea how this would assemble. So we take out all the screws. Now these shorter ones, these shorter gold ones, would be going on the underside of the PCB, poking up through the top of the PCB. You grab one of these longer ones and you thread them together like that. So I'll just do that for all. So I will leave a link in the description to where I found this if anyone's interested in purchasing it, but this is going to be after I've actually tested it, because I want to make sure that this actually even works. And I've got a spare screw, so I'll stick that back in one of the polythene bags, stick it back in the box. Open the other polythene bag. Now they give you a screwdriver, which I'm assuming is for the pots, or it might actually be for this, because that's our adapter. Or actually, it might be for these screws too. Do you feel like an idiot sometimes? Because I do. Right, so I'll turn all these controls right down to their 0 position. So it helps with lining up these pot knobs. So I'm going to place, so we'll put that module to the side. Now we know what the IC is, and we'll look that up. So these are actually standoffs. So they go on the main PCB here in these 4 points to mount this other part, which we've actually got 2 panels here. We've got a back panel. It tells you what the DC voltage is between 12 and 24 volts, and its power outputs at respective, loads and stuff. So these are also PCB material. So we've got a back panel and what would be, well, the bottom panel, and this will be the top panel. Turn it the right way up. It's got your power input at the back here and the auxiliary input, and then it tells you all the output connect. And then it tells you the output connections here, right, left subwoofer. At the front of the board, it's like telling you what the controls do, etc. So you've got off and on. So the next thing I would do probably is, I'll put that to the side for a minute, is work out how this would assemble. Now I've got a fair idea how this would assemble. So we take out all the screws. Now these shorter ones, these shorter gold ones, would be going on the underside of the PCB, poking up through the top of the PCB. You grab one of these longer ones and you thread them together like that. So I'll just do that for all the other 3 remaining connectors. Is with my multimeter in continuity mode, I want to just verify where grounds are. So this may be a floating ground system. And yeah, according to that, it is, because it's not actually connected to the negative connection. It's not connected to the positive either. They're not connected to each other. So yeah, this is all floating ground. So if, say, for example, why you'd want to, I don't know, but if you used it in a car, well, you do not want to have the speakers grounded to the chassis of the car and the negative rail, because you'll short the thing out. So that's good to know that this is floating negative, so do not connect the grounds together. I reckon we should really need to look at the datasheet first before doing anything else at that particular IC, just to see how it's configured. I reckon that these are actually probably a bridge-tied load Class D amplifier chip to start with, but let's verify that before we do anything else. Alright, so this is a look at the datasheet for the CS8673e, and it's all in Chinese. So if we look at how the block diagram is wired, you've got input L in NL, so that would be your negative lead and positive lead, so they've named it in positive lead, in negative lead, and it is stereo. There's a control pin and a PVCC pin, which is the power, and you've got output from the IC itself as positive lead, negative lead. So yeah, internally this has its own ground reference, so you cannot ground the thing together because it will not work. And I can't read Chinese, but it looks like that's a stereo version up here. That's a stereo version up here. Down here is a bridge-tied load version. So this is how they'd be wiring it on the board. There's no equivalent schematic for it. All the absolute maximum ratings are in Chinese, which is not very helpful. So this is a Chinese bred Class D amplifier chip, and so this data sheet is pretty much practically useless unless you can read Chinese. Looks like a minimum input sensitivity is 200 millivolt peak to peak for a gain of 70 decibels out by the looks of things. Anyhow, that's the data sheet. It's not very helpful, but it does tell us that yes, it looks like it is already internally bridge-tied load. So that means the outputs, let's look at the stereo version, the outputs on the positive and the negative part are actually two separate output amplifiers because they've got their own filter networks here. So this would be internally bridge-tied load, so when they bridge-tied load it for the subwoofer, like is in the diagram down here, well, you've actually got two bridge-tied load amplifiers together, and yeah, that would probably put the impedance that the amplifier sees, if it's an 8 ohm speaker, at 1 ohm, and in stereo with it connected where it should be, probably a 4 ohm load. That's usually how bridge-tied load works. Well, actually no, it'd be 2 ohm, not 1 ohm. Anyway, so yeah, that gives us some sort of idea of what the IC is and what it's doing. So let's hook it up to a power supply and just see what we can get as an output. Alright, I've got everything set up. I found my 3.5mm to 3.5mm lead. That plug was awfully stiff to get in the socket, but anyway, I've got the power supply sitting over here, preset to 12 volts, scope in the background, but I don't know if it's set to the correct time base. So the switch is already on, so we'll just turn the power on. And well, currently, apart from a bit of noise there, whoa, what the heck, it must have like a mute function, but wow, that is so noisy. It looks like it's got a lot of switching noise and I don't even know what frequency I'm on. That is horrible, whatever the heck that is. Bass doesn't seem to have any effect on it. treble doesn't have any effect on it. It is saying we're at a frequency of 1 kilohertz, but it is changing with my oscillator. But yeah, that is really noisy. Even on the subwoofer's output and even on the right hand channel output, it's just got so much switching noise. Well, with the speaker driver hooked up, it doesn't sound terrible. Hear that switching noise. So let me try look at that woofer go. So it's doing something, but I just cannot get a good waveform on the oscilloscope. Alright, that's 100 Hertz roughly coming out of the right hand speaker, and my oscilloscope is saying something totally incorrect. Even with the volume down, I'm still getting random noise on the output. You know what I think's happening? Is because this oscilloscope maximum resolution is about 200 kilohertz, and this is probably operating around about 255 to maybe 500 kilohertz. It's confusing the ROM chip inside this oscilloscope here, so it's not giving me a valid reading. Because even with the volume down, so there's no signal coming out, well, now it's just buggered off. But I turn it down and it's confused. It doesn't know what to do. So I'd really need a better oscilloscope to measure this. But I think what I'm picking up here is mostly the switching frequency. Okay, so just before I put the oscilloscope away, I've just done a review video on this, so I'm not really sure how well that turned out. I'm going back to measuring this ZK-MT21 Class D 2.1 stereo amplifier module, because I've noticed that there is no LC filters on its output connections. So I bet you anything the reason why my little oscilloscope was not measuring anything properly is because we're going to see a bunch of switching frequency here on the output. So I'll turn it on. It's 15.6 volts, and just wait for this to do something. Well, it doesn't appear to be doing anything. There's no switching noise or anything that I can see on the scope. Oh wait, no, never mind, there is a bunch of noise. Look at that bunch of noise there. Well, according to that, it's saying it's around about the 22 kilohertz range, but I reckon it's more around about the 500 megahertz range. There is some filtration going on there, but it's not the best. So what I'm going to do is I'm going to hook up the generator. It's currently set to 1 kilohertz to the input of this thing, and see if we get a signal output. Yeah, we do, but look at all the noise on it. Yeah, that's a bunch of switching frequency. That's why my other oscilloscope was having such a hard time. So this is the reason why we have an LC filter on the output of Class D amplifiers, guys, is because we want to get rid of all this crap. So unfortunately, this is currently unmeasurable. So I can't actually measure it because it's not actually telling me what the frequency coming out of it actually is. That's because it's confused with all this other bullshit that's going on the screen, which gets even worse when you change the voltages per division. But I mean, even if I change the time base, it's just noise, a bunch of switching noise. So that is not very good, not very good at all. So what do I actually now think of this amplifier? Well, the fact of the matter is that there's a bunch of frequency switching noise on the output, and I can't get a decent measurement of what it's actually outputting in voltage, because yeah, it's just not clean, and the volume control makes it worse. I'm going to say that this module is a piece of crap. I personally would not hook this up to a speaker, not with all this nonsense going on, because that'll be going through the voice coil and be heating the voice coil up over time, because the heat's got to go somewhere. Like all this crap's got to go somewhere, and at the moment it's going into the dummy load. So this is unmeasurable. I can't even measure the power output of this thing. The data sheet for the IC they're using does actually show an LC filter on its outputs, but there are no coils that I could see or any inductors marked as L on the main circuit board anywhere. So yeah. I've also sprayed the top of this panel with some clear coat, and I like what it says here, treble bass regulation. Yes, but that waveform is horrible. That's got to be the biggest load of bollocks that I have ever come across in a long time, from a design standpoint. This is bollocks. Yeah, I mean, with it all bouncing around like that, it won't even trigger properly. Well, I can make it trigger there, but it's still not perfect. But yeah, that's just terrible. What I'm going to do now is I'm not really going to go any further with this thing. Ooh. Yeah, okay, that just went nowhere. There we go, let's got rid of that. What happened when I do that? Oh, it must be the filter capacitor discharging or something. And that noise that we saw before was just basically the noise of the probe here, so that's nothing to worry about. So what was I saying? Yeah, I'm not going to go any further with this. I'm not going to hook up a speaker to it, because I personally would not hook up any speakers that you value to this thing, because it will over time eventually destroy the bass drivers. So yes, it was 22 bucks from eBay somewhere. I can't remember where now, it was a few weeks ago. I've reviewed it. Yeah, it does work, it does output sound, I found that out. But the waveform is just terrible. It's not worth the effort or the investment of money into it. So yeah, I'm going to basically end this video here. Unfortunately, we're not going to do a sound test on it hooked up to a subwoofer or anything, because I don't want to destroy shit. So anyway, I'm the Astro 30. If you enjoyed this video, please remember to rate, comment and subscribe below if you haven't done so already. Anyway, this is the Astro 30 saying, see ya, have a happy new year.
Dunk, no. Kiss my sweaty balls, you fat f***.